So today we'll be discussing what do you have any guess? So you can see here there's bouncing some certain structures. Can you guess now? So I'm giving you a hint. Yes, these are the alicyclic hydrocarbon. So why these are called alicyclic hydrocarbon? Because they are cyclic in nature. Whenever we have a straight chain hydrocarbon, those are called alkane. Whenever we have hydrocarbons which are cyclic in nature, we call them as cycloalkane. Depending upon the functional group, the cyclo compounds are named as such. Example, if we have three carbon atoms which is making a cyclic structure, then the name will be given as cyclopropane. Similarly, if we have five carbon atom which is forming the ring, then it is called as cyclobutane. Similarly, if we have four carbon atom which is forming the ring, then it is called as cyclobutane. Sorry, if it is as five carbon atom, then it is called cyclopentane. So this is called cyclopentane. Similarly, if we have six carbon atom which is forming the ring, then it is called as cyclohexane. More complicated one. So in this case, you can see there is a ring which is formed by three carbon atoms. So this is the skeleton of the parent compound. And with this, one methyl group is attached here. One methyl group is attached here. So methyl group is acting as a substituent here. That's why the name of the compound will be methyl cyclopropane. Similarly, if you see this structure, it is made up of five carbon atom which is forming the ring, which is the skeleton of the compound, and to the skeleton one ethyl group is attached. So this is called ethyl group. This is acting as a substituent here. That's why the name of the compound is ethyl cyclopentane. If you look at the left side one, the structure of which is present on the left side, what you can see here, basically this is a cyclobutane structure. To this one functional group OH is attached. So when the functional group OH is attached, when the functional group OH is attached, then it is known as cyclobutanol. Similarly, which is present at the extreme bottom, right side bottom, the structure, the parent compound is cyclohexane. To this, two methyl groups are attached. So you can see this is the parent structure, and to this, two methyl groups are attached. One methyl is here, and the another methyl group is here, right? So this one will be called as, so first you have to number this one, two, you have to number in such a way that the substituent will get the least number. That's why you have to start from one of the substituent, 3, 4, 5, and the last one is 6. So you can see here the substituents are attached at one position as well as four position. So the name of the compound will be 1,4-dimethyl cyclohexane. If you know the structure, then if you know how you have to number them, then you can easily write down the structure. Preparation method. So in our syllabus we have only two kinds of preparation method. The one is friend method and the other one is Wisliessness method. So what is these methods? So basically these are the variation of some method which we have already studied. So you would have heard about Wood's reaction, right? So this friend method is the variation of Wood's reaction. In this case, in one molecule only you have to conduct the Wood's reaction. And in the Wisliessness method, dry distillation of calcium salt followed by hydrogenation. So that will give rise to cyclohexane. So let us see one by one. Friend method. So in any chemical reaction, what you need to focus is, first you have to focus on the what is the substrate the reaction in the reaction is used, and what are the reagent used in that reaction, and finally what is the product you are going to get out of that reaction. So in this case, that is in front method, that is the preparation of cycloalkane, you are using dihaloalkane as the substrate and zinc or sodium metal as the reagent, and the reaction medium is the ether medium. Finally you are going to get the cycloalkane. So as you can see here in this example, basically this is the compound where the end carbon atom are substituted by a halogen. Whenever you are reacting this reaction with sodium or zinc, so what will happen, these bromine atoms will be eliminated from these two carbon atoms, and to satisfy the valency, these two carbon atoms will form bond with each other. That's how a cyclic alkane is formed here. Depending upon the value of n, you can name the compound. So this overall method is known as front method. The Wislitzner's method, the substrate used here is calcium salt of carboxylic acid. The reagent used here is zinc and mercury along with HCl. Basically what it will do, it will act as a reducing agent. So reducing agent, I have already told you that the agent which will cause oxygen to out from a compound or which will cause hydrogen to in a compound is known as reducing agent. So you will be seeing how it is able to do reduction. So in this case you have taken the calcium salt of carboxylic acid. So basically this is a dicarboxylic acid. So in one end one carboxylic acid group is present, in the other end one carboxylic acid group is present. The H is substituted by Ca. That's how we are going to so that's how we are getting a calcium salt of dicarboxylic acid. Whenever you will heat this kind of salt, so what will happen, will calcium carbonate will be eliminated from this compound. So whenever calcium carbonate will be eliminated, so what will happen, this part will eliminated out, and this CO will form bond with this CH2, and that's how we get a compound like this. And after that what happened, whenever you treat it with zinc and mercury along with HCl, as I told, this is a reducing agent. So what it will do, it will take out the oxygen and it will add two hydrogen to this carbon atom. That's how this compound will look like this. I am sorry. So there will be a CH2 group here. So this CO group will be converted into CH2 group. So these two CH2, the up CH2 and down CH2 group will be linked with this CH2 group. That's how we are going to get a cycloalkane.